we are discussing about the diode equation. What is this diode equation? We have already observed two electrical properties, voltage and current. So this mathematical equation is representing how the current in the diode is varying with respect to the voltage. And if you observe clearly, the relation is exponential. So this equation is like y is equal to e to the power x. So whenever we are varying the x, the y is varying exponentially. So in this diode, whenever we are trying to vary the voltage, diode voltage, the current is varying exponentially. So what is this IS? Reverse saturation current. We have already seen in the last class, when the diode is operated in the reverse bias, until the breakdown voltage, even though we are incrementing the voltage, the current will not be affected, because the current is due to only minority carriers. And this current is called as reverse saturation current. This reverse saturation current value does not depend on the applied voltage. So this IS is reverse saturation current. And this neta is intrinsic coefficient, or it is also called as emission coefficient. Its value will be 1 or 2 depending upon the semiconductor we are using. And Vt is the thermal voltage. Vt is thermal voltage. So Vt is equal to kT by Q. Here K is the Boltzmann constant, T is the room temperature in kelvins, Q is the charge of the charge carrier, which is nothing but an electron, 1.602 into 10 to the power minus 19 coulombs. So its standard value at room temperature is 26 millivolts. So this Vt is constant and intrinsic coefficient value is constant. Reverse saturation current is constant. The only variables in this equation are Id and Vd. So whenever we are varying the Vd, the Id is varying. This is in forward bias. In the reverse bias condition, whenever we are giving the voltage, that is negative value. Because this voltage is negative, e power minus we are giving, that is very small amount compared to 1. So this term is negligible almost. So when this is negligible, Is equal to 1 minus 0. So finally it is Is. So in the reverse bias, the diode current value is Is. So this reverse current value is Is. The reverse current value is not depending on the applied voltage. This is mathematically we are representing. We have theoretically seen and we are representing mathematically. So this is the diode equation. Is means reverse saturation current. Vd means diode voltage. Neta is intrinsic coefficient or emission coefficient. Vt is thermal voltage. What is the thermal voltage value at room temperature? 26 millivolts. What are the variables in this equation? Only we have two variables. One is diode voltage and the diode current. So when we are varying the diode voltage, the diode current is varying. That variation is in exponential. Now we are observing the VI characteristics of a PN diode. So VI characteristics, voltage versus current characteristics. Already we have mathematical equation. What is the use of this VI characteristics? We are taking this VI characteristics practically. Practically we are varying the voltage value and practically we are reading the current. After that we are drawing a graph. In that graph we are checking the theoretical values are matched, whether theoretical values are matching or not. For that first we have two conditions. We can connect the diode in forward bias or in reverse bias. So first we are seeing in forward bias. Diode is connected in forward bias. For that, I am taking a diode. This is the electrical equivalent electrical symbol of the diode. This is anode and this is cathode. I am taking one resistor, 1 kilo ohms. This is RPS. To know the voltage, I am connecting the voltmeter. ammeter positive terminal should be connected to the towards the RPS positive terminal side. And for finding the current, I am taking ammeter. This ammeter can be connected anywhere in the circuit to measure the diode current. So this is the circuit. First we have to connect. After connecting this circuit, we are varying the RPS. While varying the RPS, we have to note down the diode voltage and diode current. Further, this is diode voltage and this diode current. Diode voltage is in volts and diode current in forward bias is in milliamps. So we are taking the readings. While taking the readings, we observe that voltage should be taken on x-axis and the current should be taken on y-axis. While taking the readings, when we draw the readings on the graph, we observe that after 0.7 volts, suddenly the current is rising. Until the 0.7 volts, the current is very small, negligible amount of the current. But after 0.7 volts, the current is rising sharply. So this voltage is called as knee voltage or cutting voltage, because at this voltage the current is rising very sharply, and it is also called as threshold voltage. Why at 0.7 volts only the diode current is rising sharply? The reason is we have already seen in diode potential barrier. This potential barrier is obstructing the flow of the majority charge carriers. The potential barrier value in silicon diode at room temperature 0.7 volts. So when we are giving the 0.7 volts exactly in the counterpart, because this is PN diode, negative ions and positive ions. So the potential barrier is connected like this. But when we are giving the battery exactly opposite, positive terminal in this direction and the negative terminal in this direction. So exactly we are giving 0.7 volts oppositely. Because of this, depletion region width is decrementing with the increment of the voltage, and the current starts conducting, and exactly at 0.7 volts current rises sharply. And this potential, this cutting voltage value depends purely on the potential barrier. If you have potential barrier value 1 volt, then the cutting voltage is 1 volt. If the potential barrier value is 2 volts, then the cutting voltage is 2 volts. Now after this cutting voltage, the diode behaves like a resistor. Now what is the resistance value? For finding the resistance value, we are using the delta Vm by delta M. Sir, why don't we use R is equal to V by I? That R is equal to V by I. Ohm's law is applicable only for the conductors. Only for the conductors. And here it is a non-linear graph. We are taking the resistance, forward resistance, after the 0.7 volts. You should remember this. After the 0.7 volts, you have to take any 2 points, V2 minus V1. At that V2, we have to find what is the current. This is I2. And at that particular V1 value, we have to find the current, I1. So this gives the forward resistance, and it will be very small. It is in the range of the few ohms. So in the forward bias, diode is always acting like a closed switch. After this, after you are finding the resistance value, in the forward bias you are observing the resistance value is very small, and you have to match. You have to give the voltage value mathematically and find the current and match these two. Try to see whether these two readings are matching or not. Then we have observed the forward bias characteristics of a diode.